ஆக்சிஜன் ஃபேமிலி கண்டினியூ பண்றோம். இந்த ஆக்சிஜன் ஃபேமிலியில ஓசோன் உடைய ப்ராப்பர்ட்டிஸை பார்க்க போறோம். ஓசோன் உடைய ப்ராப்பர்ட்டிஸை இல்ல நம்ம ஆக்சிடைசிங் ஏஜென்ட்டா ஓசோன் ஆக்ட் ஆகுதுன்ட்டு நம்ம பார்த்துருக்கோம். நெக்ஸ்ட் நம்ம பார்க்கக்கூடியது என்னன்னா அலோட்ரோப்ஸ் ஆஃப் சல்ஃபர். சல்ஃபருக்கு போல சல்ஃபர்னுடைய அலோட்ரோப்ஸ் எடுத்துக்கலாம். சல்ஃபர்னுடைய அலோட்ரோப்ஸ்ல ஃபர்ஸ்ட் வந்து என்னன்னா ராம்பிக் சல்ஃபர். ராம்பிக் சல்ஃபர் இதுக்கு இன்னொரு பேர் என்னன்னா ஆல்பா சல்ஃபர். இந்த ராம்பிக் சல்ஃபரை எப்படி ப்ரிப்பேர் பண்றது அன்ட்டு நம்ம இப்போ பார்க்க போறோம். இப்போ ரோல் சல்ஃபர் எடுத்துக்கலாம். ரோல் சல்ஃபர் அதை கார்பன் டைசல்ஃபைட் சால்வெண்ட்ல டிசால்வ் பண்றோம், நமக்கு சொல்யூஷன் கிடைக்குது. இந்த சொல்யூஷனை எவாபரேட் பண்ணீங்கன்னா நமக்கு ராம்பிக் சல்ஃபர் கிடைக்குது. ராம்பிக் சல்ஃபர் கிடைக்குது. ஸோ ரோல் சல்ஃபரை கார்பன் டைசல்ஃபைட்ல டிசால்வ் பண்ணிட்டா சொல்யூஷன் கிடைக்குது. இந்த சொல்யூஷனை எவாபரேட் பண்ணா ராம்பிக் சல்ஃபர் கிடைக்குதுன்னு சொல்றோம். இந்த ராம்பிக் சல்ஃபர்னுடைய ப்ராப்பர்ட்டிஸை பார்க்கலாம். இதனுடைய கலர் வந்து எல்லோ. இது வாட்டர்ல இன்சாலுபிளா இருக்கும், கார்பன் டைசல்ஃபைட்ல சாலுபிளா இருக்கும், ஆர்கானிக் சால்வெண்ட்ஸ்ல பார்ஷியலி சாலுபிளா இருக்கும். ஆர்கானிக் சால்வெண்ட்ஸ்னா பென்சின், ஆல்கஹால், ஈத்தர், இந்த மாதிரி ஆர்கானிக் சால்வெண்ட்ஸ்ல வந்து இது பார்ஷியலி சாலுபிளா இருக்குது. அடுத்து ரூம் டெம்பரேச்சர்ல இது ஸ்டேபிளா இருக்குது. இது எந்த டெம்பரேச்சர் வரைக்கும் ஸ்டேபிள்னா 369 கெல்வின் வரைக்கும் இது ஸ்டேபிளா இருக்கும். 369 கெல்வின் வரைக்கும் இது ஸ்டேபிளா இருக்கும். இதனுடைய கிறிஸ்டல் ஸ்ட்ரக்சர் பாத்தீங்கன்னா இந்த ராம்பிக் சல்ஃபர்னுடைய கிறிஸ்டல் ஸ்ட்ரக்சர் எப்படி இருக்குன்னாக்கா ஆக்சியல் டிஸ்டன்சஸ் எப்படி இருக்குன்னாக்கா எல்லாமே நாட் ஈக்குவலா இருக்கும். ஆக்சியல் டிஸ்டன்சஸ் நாட் ஈக்குவலா இருக்கும். எல்லா ஆக்சியல் டிஸ்டன்சஸும் எக்ஸ் ஆக்சிஸ், ஒய் ஆக்சிஸ், ஜெட் ஆக்சிஸ் மூணுமே நாட் ஈக்குவலா இருக்குது. ஆக்சியல் டிஸ்டன்சஸ் நாட் ஈக்குவலா இருக்குது. ஆனா ஆக்சியல் ஆங்கிள்ஸ் எப்படி இருக்குதுன்னா எல்லாமே 90 டிகிரியா இருக்கும். ஆக்சியல் ஆங்கிள்ஸ் கம்ப்ளீட்டா 90 டிகிரியா இருக்குது. ஆனா ஆக்சியல் டிஸ்டன்ஸ் மூணுமே அன்ஈக்குவலா இருக்குது. இந்த ராம்பிக் சல்ஃபர்னுடைய ஸ்ட்ரக்சர் இது மாதிரி இருக்குது என்று சொல்றோம். இதுல கன்ஸ்டிடியூவன்ட் பார்ட்டிகல்ஸ் என்னன்னு பாத்தீங்கன்னாக்கா S8 மாலிகுல்ஸ் கன்ஸ்டிடியூவன்ட் பார்ட்டிகல்ஸ். அப்படின்னா ஒரு கார்னர் எடுத்தா ஒரு S8 இருக்கும். அது போல இந்த S8 எப்படி இருக்குன்னாக்கா கிரவுன் ஷேப்ல இருக்கும். கிரவுன் ஆர் பக்கர்டு ரிங்ல இருக்கும். இந்த கிரவுன் ஆர் பக்கர்டு ரிங்ல இது இருக்கும் என்று சொல்றோம். அடுத்து மோனோக்ளினிக் சல்ஃபர் ஆர் பீட்டா சல்ஃபர். மோனோக்ளினிக் சல்ஃபர் ஆர் பீட்டா சல்ஃபர் எடுத்துக்கலாம். இந்த மோனோக்ளினிக் சல்ஃபர் எப்படி ப்ரிப்பேர் பண்றோம்னா ராம்பிக் சல்ஃபர் எடுத்துக்கிறோம். இந்த ராம்பிக் சல்ஃபரை மெல்ட் பண்றோம். மெல்ட் பண்ணா உங்களுக்கு மால்டன் சல்ஃபர் கிடைக்குது. மால்டன் சல்ஃபர் இது லிக்விட் ஸ்டேட்ல இருக்கும். ஆனா இதுல வாட்டர் இதெல்லாம் இருக்காது. இதை கிறிஸ்டலைசேஷனுக்கு எடுத்துன்னு போனா உங்களுக்கு என்ன கிடைக்குதுன்னா இந்த மோனோக்ளினிக் சல்ஃபர் கிடைக்குது. இதை கிறிஸ்டலைசேஷன் ப்ராசஸ்க்கு எடுத்துன்னு போனா இந்த மோனோக்ளினிக் சல்ஃபர், இந்த பீட்டா சல்ஃபர் கிடைக்குது அப்படி சொல்றோம். இந்த மோனோக்ளினிக் சல்ஃபர் எப்படி இருக்குன்னாக்கா கலர்லெஸ்ஸா இருக்கும். நீடில்ஸ் மாதிரி இருக்கும். நீடில் மாதிரி இருக்கணும். இது வந்து கலர்லெஸ் நீடில் ஷேப்டு கிறிஸ்டல்ஸ் என்று சொல்லுவாங்க. இது வந்து கலர் இருக்காது, நீடில்ஸ் மாதிரி இருக்கும் பார்க்கறதுக்கு. இது கார்பன் டைசல்ஃபைட்ல டிசால்வ் ஆகும். இது டிசால்வ் ஆகுது அன்ட்டு நம்ம சொல்றோம். சரி, இப்போ இதனுடைய கிறிஸ்டல் ஸ்ட்ரக்சரை பார்க்கலாம். இந்த மோனோக்ளினிக் சல்ஃபர்னுடைய கிறிஸ்டல் ஸ்ட்ரக்சர் பார்க்கலாம். இதனுடைய கிறிஸ்டல் ஸ்ட்ரக்சர் பாத்தீங்கன்னா எப்படி இருக்குன்னாக்கா ஆக்சியல் டிஸ்டன்சஸ் எப்படி இருக்குன்னாக்கா A is not equal to B is not equal to C. ஆக்சியல் டிஸ்டன்சஸ் மூணுமே அன்ஈக்குவலா இருக்கும். அடுத்து ஆக்சியல் ஆங்கிள்ஸ் எப்படி இருக்குன்னு பாத்தீங்கன்னாக்கா ஆல்பா இஸ் ஈக்குவல் டு காமா இஸ் ஈக்குவல் டு 90 டிகிரி அப்படி இருக்குது. பீட்டா பாத்தீங்கன்னா இஸ் நாட் ஈக்குவல் டு 90 டிகிரி அப்படி இருக்கும். ஆல்பா இஸ் ஈக்குவல் டு காமா இஸ் ஈக்குவல் டு 90 டிகிரி. பீட்டா பாத்தீங்கன்னா இஸ் நாட் ஈக்குவல் டு 90 டிகிரி அது போல இருக்கும். இந்த மோனோக்ளினிக் சல்ஃபர் அப்படி வருது. ஆனா ராம்பிக் சல்ஃபர்ல பாத்தீங்கன்னா இப்ப ராம்பிக் சல்ஃபர் மோனோக்ளினிக் சல்ஃபர் பாத்தீங்கன்னா ABC ஆர் நாட் ஈக்குவல், நத்திங் இஸ் ஈக்குவல். ராம்பிக் சல்ஃபர்ல ஆல்பா பீட்டா காமா இஸ் ஈக்குவல் டு 90 டிகிரி. இங்க மோனோக்ளினிக் சல்ஃபர்ல ஆல்பா காமா ஈக்குவல் டு 90 டிகிரி. ஆனா பீட்டா வந்து 90 டிகிரி கிடையாது. சரி, அடுத்து இந்த மோனோக்ளினிக் சல்ஃபர், இந்த பீட்டா சல்ஃபர் எப்போ பாசிபிள்னா it is stable above 369 Kelvin. இது வந்து 369 கெல்வின்க்கு அப்புறம் தான் இது எக்ஸிஸ்ட் ஆகும். it is stable above 369 Kelvin. சரி, below 369 கெல்வின்னா இது ஸ்டேபிள் கிடையாது. சரி, அடுத்து இப்போ ஆல்பா சல்ஃபர் எடுத்துக்கிறோம். இந்த ஆல்பா சல்ஃபர் it is stable up to 369 Kelvin. up to 369 Kelvin it is stable. Above 369 Kelvin it is converting into beta sulfur. Above 369 Kelvin it is converting into beta sulfur. This beta sulfur is stable above 369 Kelvin. Below 369 Kelvin beta sulfur is converting back into alpha sulfur. So அப்போ 369 கெல்வினோட டெம்பரேச்சர் 369 கெல்வினோட கம்மியா இருந்தா ஆல்பா சல்ஃபர் ஸ்டேபிளா இருக்கும். டெம்பரேச்சர் 369 கெல்வினை விட அதிகமா இருந்துச்சுன்னா பீட்டா சல்ஃபர் ஸ்டேபிளா இருக்கும். அப்போ 369 கெல்வின்ல both forms coexist. And therefore 369 Kelvin is called a transition temperature of sulfur. So below 369 Kelvin sulfur exists in the form of alpha form. Above 369 Kelvin sulfur is in beta form. Okay, sir. அப்போ இந்த இங்க ஆல்பாக்கும் பீட்டாக்கும் டிரான்சிஷன் டெம்பரேச்சர் என்னன்னாக்கா 369 கெல்வின் ன்னு சொல்லலாம். சரி, நெக்ஸ்ட் பிளாஸ்டிக் சல்ஃபர். Now we will take sulfur, we will take this sulfur, we will boil it. So the boiling sulfur we will take now. This boiling sulfur is poured into cold water. So we are taking sulfur, it is boiled. The boiling sulfur is poured into cold water. We are getting plastic sulfur. The plastic sulfur is soft, but it is brittle. Plastic sulfur is brittle. When it is brittle in the sense, if it is left in room temperature for long time, if plastic sulfur is left in room temperature for long time, it is a brittle, we can say. Next, this we have discussed. Now rhombic sulfur we have discussed, then monoclinic sulfur, then plastic sulfur, like this we discussed. In rhombic sulfur and monoclinic sulfur, constituent particles are S8 molecules. So sulfur constituent particle is only S8 or others also possible. Means others also possible. From where to where in the sense 6 sulfur atoms to 20 sulfur atoms possible. 6 sulfur atoms to 20 sulfur atoms possible. These exist in the form of ring structure. So 6 to 20. If we take S6, it is chair form. This we can say chair form. S6 in the sense it is in a chair form, we can say, like this chair form. Here sulfur atom at the corners, at the edges, here sulfur atoms will be there. At the corner sulfur atoms will be there. So this we can say S6 chair form, we can say. Like this 6 to 20 sulfur possible. That means sulfur molecule contains 20 sulfur atoms. Like this. These are ring structures, we can say. These we can say ring structures. Sorry. Next, at high temperature, in the sense nearly 1000 Kelvin, sulfur mainly contains S2 species like oxygen. How oxygen exists in the form of O2, like this sulfur exists in the form of S2, we can say. So oxygen O2 contains 2 unpaired electrons in its pi-star molecular orbitals. Like that S2 also contains 2 unpaired electrons in the pi-star molecular orbitals. Therefore it is paramagnetic as like oxygen. Sorry. In the oxygen, pi-star molecular orbital is pi-star 2px and pi-star 2py. In sulfur, in S2, which one? In oxygen, unpaired electrons present in pi-star 2px and pi star to py. Pi star to py. What about in sulfur? In sulfur, S2 pi star 3px equal to pi star 3py we have to say. Here only unpaired electrons present because it is coming under third period. Oxygen comes under second period cell. Now in S2, this S2 is possible around 1000 Kelvin. This S2 is paramagnetic as like a O2 cell. Next we will see preparation of sulfur dioxide we will see. Now we are going for sulfur dioxide. This preparation of sulfur dioxide we will see. We will take sulfur, it is allowed to burn in air, we are getting sulfur dioxide. Then we will take sulfite, this sulfite is treated with dilute sulfuric acid. Sulfite is treated with dilute sulfuric acid. We are getting sulfur dioxide and water. Sulfite on treating with the dilute acid, we are getting what in the sense sulfur dioxide and water we can say. Sulfite in the sense which anions with the dilute acid gives like this oxide we'll see. That means carbonate, sulfite, sulfide, then nitrite. These and all with the dilute acids gives a respective substance. Carbonate gives carbon dioxide, sulfite gives sulfur dioxide, sulfide gives hydrogen sulfide H2S, nitrite gives NO with the dilute acids. So sulfite with the dilute acid gives what in the sense sulfur dioxide. Sulfur dioxide we can say. Sulfite with the dilute acid we are getting what in the sense sulfur dioxide we can say. Next we'll go for another preparation of sulfur dioxide, that is FeS2 is roasted with oxygen, is taken for roasting with oxygen. What we are getting in the sense Fe2O3 and sulfur dioxide. Fe2O3 and sulfur dioxide. This is a industrial preparation of sulfur dioxide. This method is used in industries. It is called industrial preparation of sulfur dioxide we can say. Now how FeS2 is present, that we will see. Fe plus 2, S2 2 minus. S2 2 minus we can write S single bond S, here minus 1, here minus 1 we can give. FeS2 we can write it as Fe2 plus and S2 2 minus. S2 2 minus we can write S single bond S, here minus 1 oxidation number, here also minus 1 oxidation number. This Fe plus 2 is converting into ferric oxide, here Fe oxidation number is plus 3. Here sulfur is minus 1, that is converting into plus 4. So Fe plus 2 undergoing oxidation, S minus 1 also undergoing oxidation. Oxygen is a 0 oxidation number, that is converting into minus 2. Oxygen is undergoing reduction. So we can say oxygen is undergoing reduction, we can say cell. So this iron pyrites on roasting, iron pyrites on roasting gives a ferric oxide and a sulfur dioxide we can say. Iron pyrites on roasting gives a ferric oxide and sulfur dioxide. It is in this method sulfur dioxide is prepared. So we are preparing sulfur dioxide in what method you see? Sulfur is allowed to burn in air, we are getting sulfur dioxide. Sulfite is treated with a dilute acid, we are getting sulfur dioxide. Then iron pyrites is taken for roasting, we are getting a sulfur dioxide we can say. So preparation of sulfur dioxide we have seen. Now we will see properties of sulfur dioxide. Sulfur dioxide properties we will see. Sulfur dioxide is colorless gas. It is pungent smell. It is highly soluble in water. Sulfur dioxide on dissolving in water, it gives sulfurous acid H2SO3. Sulfur dioxide on dissolving in water, it gives a sulfurous acid H2SO3. Therefore, sulfur dioxide we can call it as acidic oxide, we can say. Then, in sulfur dioxide, sulfur oxidation number is +4. Sulfur can show maximum +6. Therefore, sulfur can go for oxidation. Therefore, it can act as reducing agent. The sulfur can show least oxidation number -2. Therefore, sulfur can undergo reduction. Therefore, it can act as oxidizing agent. So, sulfur dioxide can act as oxidizing agent as well as a reducing agent, we can say. So, now, this sulfur dioxide act as a reducing agent. What are the chemical properties, chemical reactions coming under that category? We'll see. Sulfur dioxide act as a reducing agent. That chemical properties we'll see. Sulfur dioxide with chlorine in the presence of charcoal catalyst. In the presence of charcoal catalyst, what it gives means a sulfuryl chloride, SO2Cl2. Sulfur dioxide with chlorine in the presence of charcoal catalyst gives a sulfuryl chloride, we are saying. Then sulfur dioxide with oxygen in the presence of vanadium pentoxide catalyst. Vanadium pentoxide catalyst gives a sulfur trioxide. Then Fe3 plus is converted into Fe2 plus, while sulfur dioxide is converting into sulfate. Ferric is converting into ferrous. Sulfur dioxide is converting into sulfate. Sulfur dioxide, sulfur is +4, sulfate, sulfur is +6. Then permanganate. Permanganate is converted into Mn+2. Sulfur dioxide is converted into sulfate. Then dichromate is converting into Cr3 plus. Sulfur dioxide is converting into sulfate. Then sulfur dioxide is acting as a bleaching agent. How it is acting as bleaching agent, that we will see. Sulfur dioxide with water, we are getting sulfuric acid and a nascent hydrogen. Nascent hydrogen we are getting. Sulfur dioxide, sulfur is +4. Sulfuric acid, sulfur is +6. Sulfur undergoes oxidation. Hydrogen +1 converting into 0. So, sulfur dioxide with water gives a sulfuric acid and nascent hydrogen. This nascent hydrogen converts unwanted color into colorless. Unwanted color into colorless. This nascent hydrogen converts unwanted color into colorless. Therefore, we can say it is bleaching. This process is called bleaching. Why? Unwanted color is becoming colorless means the process is called bleaching, we can say. Therefore, sulfur dioxide is a bleaching agent. We can call sulfur dioxide as a bleaching agent, we can say. Sulfur dioxide is what means a bleaching agent. Sulfur dioxide bleaches this one by reduction because nascent hydrogen. Therefore, it is reduced substance. It is what in the sense a reduced substance, we can say. This undergoes atmospheric air. This undergoes oxidation with atmospheric air and again becomes color. Because it is reduced substance, atmospheric air contains oxygen. Therefore, it can go for oxidation. It is going for oxidation means again we are getting back this color. Therefore, this bleaching is not permanent. It is temporary bleaching. This bleaching is temporary. It is not permanent. Why? Because on bleaching, we are getting colorless. Unwanted color is removed. But the unwanted color again reappears after some time due to atmospheric oxidation. So this sulfur dioxide is acting as a bleaching agent, but this bleaching is temporary. This sulfur dioxide is act as reducing this bleaching agent by reduction. Okay, we are bleaching by reduction. In the previous class, we have seen about ozone. Ozone is decomposing to give nascent oxygen. This nascent oxygen removes unwanted color. This nascent oxygen removes unwanted color. Here, this color becomes colorless by oxidation. Therefore, it is oxidized. It is oxidized substance. It cannot undergo reduction with atmospheric air. With atmospheric air, it cannot undergo oxidation. Therefore, it is permanent. This bleaching is permanent. Here, bleaching by oxidation. This is undergoing bleaching by oxidation. It undergoes bleaching by oxidation, but it undergoes bleaching by reduction. Okay, therefore, sulfur dioxide bleaches by reduction, ozone bleaches by oxidation. This is permanent bleaching, it is temporary bleaching. Okay, then sulfur dioxide, some more chemical properties we will see. This sulfur dioxide converting cupric into cuprous. Cupric into cuprous. Cuprous means Cu plus. Cu plus we have to write in the dimeric form, Cu2 2 plus. So sulfur dioxide converts cupric into cuprous, while sulfur dioxide becomes sulfate. Sulfur dioxide becomes sulfate. Then this sulfur dioxide is acting as reducing agent so far. What about the capacity of reducing agent with respect to medium? That we will see. With respect to medium. In acidic medium, how it will be there. In basic medium, how it will be there. The power of reducing nature, that we will see. Now sulfur dioxide we are taking. This sulfur dioxide +4 oxidation number becomes +6 oxidation number. It is reducing agent, means it should undergo oxidation. This +4 will convert into +6 oxidation means. Let us balance this. Oxygen is 4, here 2, so 2 water molecules will write. Hydrogen is 4, but here 2, therefore 2H plus will write. So we have balanced the equation. Here plus charge is here +2 is there. Here plus charge is there. Plus charge how much means +2. So we will add 2 electrons. So sulfur dioxide acts as reducing agent by losing electrons. So in acidic medium, how this capacity will be there. In basic medium, how the capacity will be there. If medium is acidic, common ion will be there. Concentration of H plus will be high. Therefore, backward is favoring. If medium is basic, this OH minus will remove this H plus by neutralization. So concentration of H plus is decreased. Therefore, equilibrium is favoring forward. Therefore, sulfur dioxide is acting as better reducing agent in basic medium than acidic medium. So sulfur dioxide reducing nature in basic medium is more when compared to acidic medium, we can say. Then sulfur dioxide acting as oxidizing agent, that we will see. Now we will take hydrogen sulfide and sulfur dioxide. What we are getting in the sense sulfur precipitate and water. That means here this -2 sulfur is converting into 0. +4 sulfur is converting into 0. +4 sulfur is converting into 0 in the sense reduction. -2 is converting into 0 in the sense oxidation. So here sulfur dioxide undergoes sulfur undergoes reduction. Therefore, sulfur dioxide acts as oxidizing agent here. So next we will see uses of sulfur dioxide. Sulfur dioxide is used for refining petroleum. Sulfur dioxide is used for refining petroleum. Sulfur dioxide is used as bleaching agent. Sulfur dioxide is used as anti-chlor. It is used as anti-chlor. What is the meaning of anti-chlor? We'll see. You see this reaction. The sulfur dioxide removes Cl2. Therefore, we are getting sulfuryl chloride. Sulfuryl chloride is a gas which escapes away. So, by this reaction, we can say that we can remove the chlorine, we can remove unwanted chlorine, we can remove by using sulfur dioxide. So that this sulfur dioxide is used as a anti-chlor. Anti-chlor means it removes unwanted chlorine. Okay. Then sulfur dioxide acts as a disinfectant. It is acting as preservative. Then liquid sulfur dioxide is used as solvent. Liquid sulfur dioxide we can use as a solvent. Okay. Next we will go for hydrogen sulfide, H2S. Hydrogen sulfide, H2S. How to prepare hydrogen sulfide in the sense using Kipps apparatus. Using Kipps apparatus, hydrogen sulfide can be prepared. How the Kipps apparatus will be there? That we'll see. The Kipps apparatus contains totally 3 glass bulbs. Out of that, 2 will be one set, 1 will be another set. Now, first 2 glass bulbs we'll see. It is one glass bulb. It is one glass bulb. It is another glass bulb. Okay. This will be placed here. It can be placed over the bottom. This is bottom part. 2 glass bulbs are there. Another glass bulb, how it will be there means another glass bulb will be like this will be there. This glass bulb will be placed inside this. This glass bulb will be placed inside this. Sir. Now what we have to take? That we'll see. Now let us place this glass bulb inside this we will place. It is one glass apparatus. It is another glass apparatus. Okay. Now let us place this glass apparatus into this glass apparatus. So we are placing okay. We have placed 2 glass apparatus we have placed. We have placed one glass apparatus over another glass apparatus. We have placed like this. Then this part is closed. It is closed like this will be there. Like airtight, like that will be there. Here, like airtight, like that will be there. Then here what we have to do means here this part here before inserting this glass vessel. Otherwise, after insert this glass vessel, let us insert through this FES sticks we have to add. FES sticks we have to add through this one into this middle bulb. FES sticks means ferrous sulfide. This ferrous sulfide will be just like a stones form manner. It will be there like stones. That stones will add into like this. In the middle bulb we will add. Okay, FES sticks we have added. Then this part we have to close it. How we are closing? You see here one tube will be placed like this. One tube will be placed. Okay, like this will be there. Sir. Next, here we have to add dilute sulfuric acid. dilute sulfuric acid solution we have to add. That dilute sulfuric acid solution we have to add up to how much in the sense, here we are not adding dilute sulfuric acid. Correct only. Here only we are adding dilute sulfuric acid. This full we will fill with dilute sulfuric acid. This complete thing. This complete thing, and we are adding dilute sulfuric acid not in this one. This will be, this here knob will be there. Using knob we will close this. Now dilute sulfuric acid we are adding through this one. Dilute sulfuric acid we will add like this. So how dilute sulfuric acid will be there means, here and all dilute sulfuric acid will be there. Here and all dilute sulfuric acid will be there. Okay, like this it is present. Now what happens means, because of this pressure, dilute sulfuric acid will go like this and it will meet FeS sticks. So dilute sulfuric acid is meeting that. So what happens here in the sense, this FeS contains Fe2 plus and S2 minus. This sulfuric acid contains H plus ions and sulfate. So H plus ions and sulfide becomes H2S gas. Fe2 plus and sulfate becomes FeSO4. This FeSO4, produced FeSO4 will come down and settles down. The produced H2S gas will go here and it will stay here. As time passes, amount of H2S goes on increasing. It is closed. Amount of H2S gas goes on increasing. Pressure of H2S gas goes on increasing. At one stage, the H2S pressure is such that it will push dilute sulfuric acid to go down. Therefore, dilute sulfuric acid can't be here. Dilute sulfuric acid cannot be in contact with the FeS sticks. Therefore, reaction is stopped. Now, let us open this knob. H2S gas comes out. So, we are utilizing H2S gas. Therefore, amount of H2S decreases. Pressure of H2S decreases. Therefore, dilute sulfuric acid from here starts moving up and coming to this place. FeS sticks be in contact with the dilute sulfuric acid. So, reaction starts. Once the pressure of H2S is such that it is pushing the dilute sulfuric acid down in the sense, while reaction will be stopped. Okay. So, up to certain pressure H2S will be produced. After that, after certain pressure, dilute sulfuric acid cannot be here. It will be down because of H2S pushing dilute sulfuric acid down. Okay. So, that means whenever we want H2S, we can use it. When we are using the H2S, again H2S will be produced. This method is called, this apparatus is called Kipps apparatus. It is used for preparing what in the sense H2S gas. This hydrogen sulfide gas will be used for salt analysis. For cationic analysis, we can use this hydrogen sulfide gas. We can use, sir. This hydrogen sulfide is colorless gas. It is having Roten smell. It is slightly soluble in water. It is having acidic nature. It is a dibasic acid. That means it reacts with the sodium hydroxide. In what manner we'll see. This H2S with the sodium hydroxide gives sodium bisulfide and water. This sodium bisulfide with the sodium hydroxide gives what in the sense sodium sulfide and water. So sodium hydroxide with H2S gas gives sodium bisulfide. Sodium bisulfide with the sodium hydroxide gives sodium sulfide. So H2S can give 2 H plus ions. Therefore, we can call this is as a dibasic acid. We can call H2S. We can call it as dibasic acid. Next, in H2S, sulfur oxidation number is -2. In H2S, sulfur oxidation number is -2. Therefore, it can undergo only oxidation. It cannot undergo reduction because sulfur minimum oxidation number is -2. Here in H2S, sulfur is in minimum oxidation number, so it can undergo only possibility oxidation. Therefore, it can act as reducing agent but not oxidizing agent. So now H2S with halogen, its chemical property we'll see. So H2S becomes a sulfide becomes sulfur, halogen becomes a halide. So hydrogen halide is possible. This hydrogen halide is possible here. The sulfur -2 here. Sulfur oxidation number is -2, that becomes 0. Then halogen oxidation number is 0, that becomes -1. Okay, so halogen oxidation number is 0, that becomes -1. We are saying sulfur oxidation number -2 becomes a 0 oxidation number, we can say. Sir. So H2S acting as a reducing agent, we said here, because in H2S sulfur undergoes oxidation. Sulfur undergoes oxidation, we can say. So next chemical properties of FeCl H2S we'll see. Next chemical property, ferric is converted into ferrous. Ferric is converted into ferrous, while hydrogen sulfide converts into sulfur. Hydrogen sulfide converts into sulfur. Next, with corn nitric acid, what is the reaction? We'll see. With concentrated nitric acid becomes NO2. Hydrogen sulfide becomes sulfur. Hydrogen sulfide becomes sulfur, we can say. Then corn sulfuric acid becomes sulfur dioxide. Hydrogen sulfide becomes sulfur. Hydrogen sulfide is precipitated as sulfur. Then potassium permanganate. Permanganate is converting into Mn+2 in acidic medium, while hydrogen sulfide is becoming sulfur. Dichromate becomes Cr3+ in acidic medium, while hydrogen sulfide becomes a sulfur, we can say. So hydrogen sulfide becomes sulfur, while halogen becomes halide. Ferric becomes ferrous. Corn nitric acid becomes NO2. Corn sulfuric acid becomes sulfur dioxide. Permanganate becomes Mn+2. Dichromate becomes Cr3+. Okay. Next we will see test for H2S. What are the tests for H2S, hydrogen sulfide? That we will see. H2S turns lead estate paper black. Hydrogen sulfide turns lead estate paper black. What is the chemical reaction? That we will see. H2S with the lead estate. H2S with the lead estate gives PBS plus acetic acid. PBS plus acetic acid. Then this H2S will take in the form of salt, Na2S will take in the form of salt. This salt converts sodium nitroprusside, that means nitroprusside solution. We are taking what in the sense a nitroprusside solution. This sulfide is passed into nitroprusside solution. We will get violet color. The violet color complex, violet color is due to complex. That complex is this one. That complex is this one. This complex is having what means violet color. This complex is having violet color. So sulfide converting this nitroprusside, solution into this violet colored complex, we can say. Then we'll go for oxo acids of sulfur, in which we'll take sulfuric acid. Sulfuric acid, we can call it as a oil of vitriol. That preparation we'll see. Preparation of sulfuric acid we'll see. Preparation of sulfuric acid. Sulfuric acid, we can call it as a oil of vitriol. Okay. Manufacture of sulfuric acid by which process? In the sense contact process. By contact process, we are manufacturing sulfuric acid. Okay. In this contact process, first step is what means sulfur is burned with air. Sulfur is burned with air, we are getting sulfur dioxide. Otherwise, roasting of sulfide ores, iron sulfide, iron pyrites is roasted. What we are getting means iron becomes ferric oxide, sulfur becomes sulfur dioxide. Okay. Now, the sulfur dioxide is having, if arsenic impurities, if sulfur dioxide is having arsenic impurities, that must be removed now. To remove that, what is used means gelatinous hydrated ferric oxide. We are using gelatinous hydrated ferric oxide to remove arsenic impurities. After removing arsenic impurities, sulfur dioxide is taken for converting into sulfur trioxide by reacting with oxygen. Here, what is the catalyst used means vanadium pentoxide is the catalyst used. Otherwise, platinized asbestos. Platinized asbestos we can use. Here we have to give optimum temperature nearly 700 Kelvin and optimum pressure we have to provide nearly how much in the sense 2 bar. Nearly 1 bar we are providing. Sorry. Why we are providing optimum temperature and optimum pressure means this is equilibrium. This will attain equilibrium. So the equilibrium will be favored when the pressure is 2 bar and the temperature is 700 Kelvin. Then this sulfur trioxide will be treated with corn sulfuric acid. Then it is converted into oleum. Sulfur trioxide is converted into oleum now. This oleum, on diluting with water, we are getting a sulfuric acid. Oleum is treated with water. We are getting what in the sense sulfuric acid. The sulfuric acid is 96 to 98% pure. So here obtained sulfuric acid is 96 to 98% pure. Okay. Now, this step, actually we are using this contact process for manufacturing sulfuric acid. But in this step, we are using corn sulfuric acid. We are converting SO3 into H2SO3O7. Then we are treating with water, we are getting sulfuric acid. Why can't treat sulfur trioxide directly with water? We will get sulfuric acid now. Sulfur trioxide, if we treat directly with water, we will get directly sulfuric acid now. Why to do like this? Sir, why we are not doing like this? That will say we have to do like this only. We have to do. We should not do like this. Why? Because sulfur trioxide on dissolving in water, we are getting sulfuric acid, no doubt. But in this process, lot of heat will be liberated. Due to that heat, sulfuric acid escapes to atmosphere. Sulfuric acid is evaporating. Therefore, only we are not doing like this. So sulfur trioxide, we are not treating with water directly. Why sulfur trioxide we are not treating with water directly? In the sense the obtained sulfuric acid escapes to atmosphere due to very high heat is liberated. So in this reaction, lot of heat is liberated. Therefore, sulfuric acid is evaporating. It is escaping into atmosphere. Therefore, only. Okay, so that how to prepare sulfuric acid from sulfur trioxide means sulfur trioxide is treated with corn sulfuric acid. We have to get oleum. The oleum we are diluting with water. We are getting sulfuric acid. The obtained sulfuric acid is 96 to 98% pure, we can say. So the obtained sulfuric acid we are saying 96 to 98% pure, we are saying. Okay.